AI is all the rage. Definitely an understatement. But in my personal opinion, AI really makes sense when it comes in touch with the physical world, when it's in our environment, not just running in the cloud. The cloud is great for training models, it's great for optimizing them, but the inference happening at the edge, you cut on latency, you cut on the connectivity you need to have, and on cost as well. We'll see how. But running these models on tiny devices with low energy available, with low memory available is a challenge. Getting a GPU on this kind of devices to accelerate inference at the edge is also challenging. These GPUs are expensive, they consume a lot of energy, and they heat up a lot. There's a new type of chip called NPUs, Neural Processing Unit. You certainly have heard about them. Sang Hyun from Mobilint is here to tell us about how they do NPUs at Mobilint and how they build a software stack and make it available for developers to optimize their model for their NPUs, as well as how they can leverage their development kits, their boards, and their PCI form factor, and so forth. So that's today on the IoT Show. If you like the episode and the show itself, and if you have not done so yet, please subscribe, give us a like, leave a comment, let us know what you think. Thanks for watching. Hi everyone, this is the IoT Show. I'm Olivier, your host, and today we want to talk about NPUs, and for that we have Sang Hyun from Mobilint. How are you, Sang Hyun?
I'm good. How are you?
I'm great. I'm good. I'm in the middle of the afternoon. So you're calling in from Korea, right?
Yes, we're stationed in South Korea.
Okay.
Yeah, so it's right now it's in the morning.
In the morning, not too early, I hope.
Yeah, pretty much.
Okay, thank you then even more for your time today. So we want to discuss a little bit, the context is Edge AI, and we want to discuss your solutions for accelerating AI at the edge. But before we get into that, and before we get into Mobilint and its solutions, I want to know a little bit about yourself. So who's Sang Hyun, and where are you coming from? And then we'll talk about Mobilint.
Yeah, so thank you for the brief introduction. My name is Sang Hyun. I'm the CSO, which stands for Chief Strategic Officer in Mobilint. Our company is in South Korea, as I mentioned. And before joining Mobilint, I was also I worked in Samsung Electronics for a while, and in semiconductor business. And after working there, I had an opportunity to meet our CEO, Dong-Ju Shin, and he shared his vision with me about the potential of AI in the edge, and how he developed his product. And yeah, I was pretty impressed, so I decided to join this company 2 years ago.
Awesome. Yeah, recent, but as we'll see, you guys are already well advanced in delivering solutions. So tell me a little bit about, from your perspective, your experience at Samsung, and then you transitioning to Mobilint, really believing in Edge AI. Why is AI at the edge that important?
While I was in Samsung Electronics, one of my job was to seek for startups, like Mobilint, for instance. And I had a opportunity to meet a lot of AI companies, including companies who makes AI semiconductors. And they were all very impressive. But one of the main thing was that I just couldn't see how they can overcome the performance and achievements that GPU has achieved. But what I realized after I spoke with our CEO in Mobilint is that Edge AI is necessary for us to implement AI into our daily life. What I'm saying is you can make AI models, very advanced, very complicated, so it can mimic how we think and, replace some of the works that people does. But the problem is implementing it into our life, and that comes with it has a very different constraints. For instance, like the cost, the power consumptions, and etc. And but when you have implement your these AI models into our life, it is very critical that uh, that it runs on a very low latency in a real time basis, and also you have different nodes like for instance, like your cell phone, your computer, your car. It's very time critical and power critical and cost critical as well. And the traditional GPU doesn't solve that. So on the edge, what you need is a solution like NPU, which is more, cost efficient and power efficient, and which is really optimized for AI application itself.
Okay. Okay, that makes sense. So latency for your models, you want to run them locally to make sure that you don't have a latency back and forth to a cloud when you're connected, right? Critical systems do need that. You were mentioning, autonomous vehicle, a car. You don't want it to ask the cloud for, hey, do I need to turn right here, or should I brake because there's an obstacle? So you want that AI to run locally. You mentioned the cost of cloud inference as well. And data privacy, right? Let's not forget data privacy. Super important to keep the data locally. Hence the need for running AI inference at the edge on devices. And I like how you position that in our life, right? Around ourselves, around us. That's a pretty cool way of putting it. And so yeah, the challenges though are, you were saying GPUs are not cutting it because they're expensive and they consume a lot. Am I right?
Yes. So I think just yesterday, I think Google and some other cloud service providers have announced that they are planning on spending billions and billions of dollars on setting up AI infrastructure, and I'm pretty sure a large sum of that is due by using or purchasing GPU or very high speed graphic processors. Yeah, and I think NPU can solve some of the problems that they're facing wise.
Okay, let's see how actually. So tell me a bit about NPU. What does it stand for, and what are the main differences with GPUs?
Yep. So NPU is stands for Neural Processing Unit. So the main difference between the GPU and NPU is GPUs were built for graphics and general processing with massive parallelism that requires huge memory bandwidth and also has constant power, consumes constant power. But NPUs are specialized for tensor operations, for which is mainly for AI application. And architecturally, I think the difference is NPU architectures make sure to like reuse data whenever possible. So like instead of constantly like fetching data from like external DRAM, NPU keeps data on chip as much as possible and maximizing the performance per watt. Hence, also maximizing the utilization as well.
Yeah, that makes sense. So yeah, hyper parallelism with GPUs, like doing a bunch of things at the same time, consuming hence a lot of energy, which if you don't have a big battery on your car, for example, you can run with a GPU, but you also need to have big fans to cool down all that electronics. So NPUs are more optimized. Yeah, so. Tell me a bit about, the fact that you have GPUs and NPUs. GPUs are still necessary for the training phase, right? Is it logical to think about GPUs have a place in the cloud where you can do training on these, highly performant type of hardware, but expensive as well, and keep NPUs for inference at the edge? Is that a good separation of use for both?
Yeah, I don't think NPUs are meant to replace like all GPUs or like cloud instances per se. Each option has its own strength, I think, and we view them to work them as a hybrid world, for instance. So like you mentioned, I think GPU is more suitable for training in the data center, but NPUs are more for like mission critical inferences at the edge, I think.
Cool. So Mobilint, you guys have been out for 2 years now. You already have products on the market. So tell me a little bit about your NPUs, and then we'll look at a little couple of demos that you brought.
Yeah. We provide NPU hardware and software for mainly for edge computing applications, and our primary focus is on implementing very high level AI within the power and thermal and, like I said, cost constraints for edge devices. And so to achieve this, we offer a vertically integrated solution consisting of course, NPU, which is called Aries and Regulus Silicon, and proprietary SDK as well, which facilitates the high performance inference for developers and engineers.
Yeah, because it's not just a matter of the hardware. You also have to prepare your models for the hardware. And so you need a tool chain that will allow you to prepare your models, train your models, and then optimize them to run on that NPU, right?
Yes. Our main, like I said, our main focus is on optimizing NPU for applications where it has constraint of cost and power. So we prioritize like TOPS per watt or FPS per watt without significant loss in accuracy.
Okay.
Yeah, the hardware. So our hardware tries to retain over like 99% accuracy of the original model, even after quantizing into integer computation, allowing for model migration from like GPU, which was the models that were trained from GPU, like without sacrificing, too much accuracy. So, like I
That makes
said,
sense.
so as we are a vertically integrated provider, so we design our own silicon and software stack as well.
Yep.
Yeah,
That's awesome.
and
And you go all the way up to providing a edge box, which is more than just the NPU, right? You have an actual CPU in there. You have an entire box eventually for development, but you can go beyond that, right? And I think you're running a demo right now exactly on this little Edge AI box. So tell me about this demo you have, so we can look and watch what's going on with that NPU and how fast it can run these models and how efficient it can be. Bearing in mind that everything runs locally, right?
yes, without internet connection.
Okay.
So this box is called MLX A1 HIA box, which has our Aries chip embedded in it. And right now on our demo, you can see we're running like 3 different models in a row. So right now it's running Whisper for speech to text. And I think for LLM is a model called Exa1, which was developed by a Korean company called LG. And also on the text to speech side, I think we're using Mellow TTS. So our benchmark for this LLM is around like 14 tokens per second with like zero internet connection, of course. And providing, I think the main thing is about providing this generative AI model on a very private environment, and hence, of course, offline.
Show us how that works on this device right now.
Okay, so let me show you how it works. So I have a microphone right here, so I can ask the question, and then it'll process through AI model, speech to text AI model, and then it'll create an answer by itself and then respond back using text to speech AI model.
Okay.
Let me just try that out real quick. What do you think about AI market So what we did here is we're trying to show people how it works step by step. So that's why we divided the screen into like three different sections. But in a real life, it won't be segmented as like three different screens.
Enhanced device capabilities and improved battery life support wider adoption across gaming, education, retail, and healthcare sectors. User engagement is likely to grow as hardware solutions become more intuitive and functional, bridging virtual and physical worlds seamlessly. This trend promises transformative impacts across industries, fostering innovation and new forms of interaction.
That's impressive. Once again, everything running locally. The model has been actually optimized for running at the edge, and every like the inference itself is accelerated with NPU, and we saw that in real time, right? And you were describing the fact that you have these three steps that are on the screen here, but in real life, if you had this kind of device next to you, you would not need to decompose the steps, and it would be way faster, right?
Yes.
Awesome. This is awesome. So like text is one of the options. Like you also can do vision. You can do other things as well, right?
Yes, and we also have demos for those as well.
Okay. I want to see that.
Yep. So we're running like 5 different models, including YOLO, 3D8, segmentation, and post estimation, object detection, for like 6 cameras at once.
Wow.
In a single AI chip. So that's like 30 concurrent operations running simultaneously.
And the frame rate seems to be pretty high as well, right?
Yeah, so right now it's running at about like 30 frames per second for each channel.
Okay. And so you're doing like you can think of scenarios such as the security cameras or in a factory floor quality inspection cameras on a production line, right? This kind of scenarios.
Yes. Yeah, and the performance, like frame per second, really depends on how heavy the AI model is and how many more channels that you want to run. But typically, many applications they require about like 30 frames per second, which is what you usually see on the screen when you watch TV. And
yes.
Or I don't know, maybe these days like it's 60 frames per second. Or
even like 30, you don't see the difference. At the human eye, you don't see a difference. Yeah.
So that's about like 30 channels running simultaneously right now on a frame rate that people are usually are used to seeing in their lives.
No, that's really impressive. Everything on one chip here, all these different video channels at that frame rate, doing actual inference on the images in real time. That's really impressive, actually, for having been working on this kind of models and trying to run them on tinier devices without an NPU in there. That's really game changing here. So that's really insightful. I have a couple more questions before I let you go. One is we're seeing that performance on that tiny device there. If I wanted to do and achieve the same thing using a GPU, what would be the difference in terms of pricing for the hardware? Like at a high level, what would be the difference here?
It's always it's lower the better actually, but what we see the threshold that we perceive is if the price of NPU is within half of what GPU is cost. I think that's generally a good starting point where people can switch from GPU to NPU. And also, if you're running AI on devices, the power consumption has to come down much lower than that. So because usually GPU runs at about say like 200 watts, 300 watts. But NPUs, including our product, they generally run at about couple tens, 20 to like 30 watts.
Wow. Okay. Battery life on a device running inference will be way higher, using an NPU rather than a GPU. And if you're plugged in a wall, you would consume way less energy, so it would cost less. Energy is not free, right?
Definitely not.
Yeah, and memory wise as well, right? Because like on your hardware, like your different components of the hardware, memory is one of them. And I know GPUs consume a lot of memory, right? So having a powerful GPU means it has a lot of RAM as well, and that adds to the BOM cost of your hardware.
Yes. Most of the high performance GPU, such as like H100, H200, they use HBM, which has a very high bandwidth memory.
Mhm.
But NPUs, which especially designed for edge applications, they usually use LPDDR, which has, maybe not a better bandwidth than what HBM has, but enough to run AI models on devices and edge applications.
And it costs less.
Because
It
much
costs
less.
less.
Yes.
Yeah. People can find, we're going to put the link to Mobilint here. You guys are not just a hardware company. We say that. You also provide SDKs. I would assume that you can help your customers as well in their integration work, right?
Yes. So actually, SDK is really a secret recipe for our solution, actually. So using our SDK, our chips has been verified with over like 400 open source models. And the true test of the SDK is its agility and programmability. Considering that there are so many new AI models that are coming out these days, and just FYI, like this January, Ultralytics has released their latest YOLO model. So we were able to port and run that model on our hardware within less than a week on its
Wow.
release. So this demonstrates the flexibility that our compiler has and our operator support.
Awesome.
Yeah.
Awesome. So that's definitely a complete solution, especially for people who want to build devices, add AI on top of it, but don't know much about AI in general. Like what you're providing definitely helps them get to business faster with a solid solution that can evolve and that leverages AI at the edge. That's my closing point. Sang Hyun, thanks a lot for your time today. We'll put that link once again about Mobilint for people to learn more. I hope people enjoyed the show today and learn about the NPUs and how they can leverage them. Thanks for your time today.
Yeah, thank you for inviting us today. This has been really fun. I don't know if I have provided any, fun facts or interesting stuff, but hopefully people can learn about how NPU has been developed and what we provide. And hope for the best for
Awesome.
everyone.
Awesome. Thanks all. Thanks for tuning in.